Today we're going to learn about percent yield. Percent yield is an equation, it's a math process that's used to calculate the amount of product that will form during a reaction. It's a value representing the theoretical yield that is obtained. Now, it's important you know the difference between theoretical yield and actual yield. One quick way is just remember theoretical yield is determined doing math, and actual yield is determined in the lab. So theoretical yield is the maximum amount of product that can be formed given the amount of reactants. In contrast, actual yield is the part that's actually formed in the lab. Percent yield. We're going to use an example. We're going to have Enrock, an alchemist, wants to try to turn lead into gold, which you can't actually do chemically. But he finds that mixing a lead with an unidentified gold compound, gold 3 chloride, actually produces a small amount of gold. The reaction is as follows. 3 gold 3 chlorides plus lead yields, and that should be a yield sign right there, if work on that yield sign, 3 lead chlorides plus 2 golds. Enoch reacts 14 grams of gold 3 chloride with, so he has 14 grams of this reactant with lead metal. I think the lead is going to be in excess. And what would be the maximum theoretical yield of the reaction? And that's under there that says lead 2 chloride and 2 moles of gold. The way we determine the grams of gold that would be produced in this reaction, we start with 14 grams of the gold chloride, AuCl3, and then we go through a 3-step process. The first step is you change grams of that to moles. It's a very heavy compound. It's 300, and I'm just going to put 4 grams of AuCl3, and that's in 1 mole of AuCl3. And then we look at the molar ratio from the balanced equation, and we see that's a 2-to-2 ratio. So we say 2 moles of AuCl3 produces 2 moles of gold. And then we know that 1 mole of gold, which is Au, has a mass of, we'll just write 197 grams of gold. And when we say 14 divided by 304 times 197, because both the 2's cancel out, we get a molar mass of 9. We see the grams of gold cancel, moles of gold chloride cancel, moles of gold cancel, and then we're left with grams. Unfortunately, Enrock only recovers 1.5 grams of gold for the reaction. Now, this is not very much because we saw previously we thought he was going to get a lot more. Some product was lost in the recovery process and the reaction did not go to completion. And possibly the AuCl3 they found was not pure. So the question is, how do you do percent yield? And this doesn't actually show up very well here, but percent yield is actual, which is what we found in the lab, over theoretical, and that's what we get doing math, times 100. Actual over theoretical times 100. A percent yield should normally be large, shouldn't be larger than 100. Let's say if you do a reaction and the product's wet and you haven't dried it very thoroughly, it could be over 100 because it weighs too much. But a lot of things could lead to it being less than 100. So for Enoch's reaction, here's what he found. He divided the actual, this is what he got using math, or we also did the problem, divided by the theoretical, and that's what he got in the lab. And then times 100. So you have 1.05, which is, and divided by 9.09 times 100 gives you 11.6. Now that is not a very good percent error. Actually, that's pretty high. So that's what we call percent yield. This is your percent yield. Now to get the percent error, which is something a little bit different, you would say this is a percent error, ERROR, is going to be 100 minus 11.6. And that's going to give us, 88.4% error. And that's not a very good percent error. And there are 2 ways to calculate percent error. Now, remember, percent error is different from percent yield. It's far Percent yield is how close you are to 100. Percent error is how far away are you from that 100. Percent error, you do theoretical. And remember, theoretical is the stuff we get doing math, minus experimental, which is what we get in the lab. The absolute value of the difference in that divided by theoretical, which is what we get doing math. And then times 100. So the theoretical value is the actual or known true value. That's what we realize it should be. Another way, which I did earlier to calculate percent error, is to say 100 minus a percent yield, and this should be an absolute value sign, equals a percent error. And that's what we did earlier. We said 100 minus, I think it was 11.6, which was a percent we found, gave us a percent error for the reaction. Let's do one more problem. Here's an example. Calcium carbonate is decomposed by heating, as shown in the following equation. Calcium carbonate, which is CaCO3, decomposes and produces calcium oxide and carbon dioxide. What is a theoretical yield of calcium oxide if 2.48 grams of calcium carbonate is heated? That's the first question. And then the second part is, well, what's the percent yield? So you always have to, if you're not given the theoretical yield, you usually will need to determine that. And that's using a gram-to-gram three-step problem. I apologize, this does not show up very well, but this is how we calculate the theoretical percent yield of calcium oxide. You would start with 24.8 grams of CaCO3, and then you do a three-step process. 1, 2, 3, and I'm just writing above a little bit better. It doesn't show that well, so you can see it. So you have 100 grams of calcium carbonate, CaCO3, and that cancels the grams of calcium carbonate there in 1 mole of CaCO3. And then we look at the mole-mole ratio from the balance equation, and it's 1 to 1. So there's 1 mole of CaCO, that should be a big O3, and 1 mole of calcium oxide, CaO. And then that gets rid of moles of calcium oxide. And then we've got one more step where we change moles of calcium oxide to grams, and 1 mole of CaO has a mass of 56.1 grams of CaO. And we do all that, the math, 24.8 divided by 100 times 56.1 gives us 13.9 grams of CaO. This is your theoretical yield, the amount you'd make if the reaction were 100% accurate. And to do the percent yield for that, it would be actual divided by theoretical times 100. So the actual would be 13.1. The theoretical would be 13.9. And then you're going to multiply that times 100. And from that, you'll get your percent yield. And I think the answer for that should be 94.2% yield. So that's your what we call the percent yield. Now, if I wanted to do percent error, it would be the difference in that, or we'd say 100 minus 94.2, and I think that would, if you just want to say that was 94, we could just say that was 6% error. Okay, so there we have percent yield and also percent error. So this is right down here, the percent error. That's it. Thanks. We'll see you tomorrow.